Hello and welcome to Australia in Space TV. My name's Chris Cubbage. I'm the editor with My Security Media. Today we're crossing to Florida, USA with Rob Mueller. This is going to be about the second annual ROBOPALOOZA.space Robotics Festival being held in Perth in the 5th to the 6th of October. This is a lead up to the Indo-Pacific Robotics, Autonomy, AI and Cyber Conference, 7th to the 8th of October in Perth, all alongside the International Astronautical Congress being held in Sydney in late September. Rob, thanks very much for joining us.
Yeah, thank you. It's a pleasure to be here.
Rob, we won't go too much into your extensive background within robotics and advanced technologies, but we can see the SwampWorks logo there on your chest. But also, you're the founder of ROBOPALOOZA, and it's quite an extensive program as well. And then I think added with that, with the IPRAAC, this is quite a number of days that are going to be held in Perth, focused in on robotics and advanced technology. Maybe introduce us to, maybe you can start with either SwampWorks or ROBOPALOOZA, whichever sort of started, but maybe what was the motivation behind ROBOPALOOZA?
Yeah, well, everything's linked. SwampWorks is an innovation environment. It's at NASA Kennedy Space Center, and that's my day job. And so in my day job, I work on regolith and robots. So regolith is the crushed rock covering the surface of the moon and other planets and asteroids. And that's where all the resources are. So if you want to survive in space, you need to get the resources from the regolith using energy from either the sun or some other source like nuclear. But the key to surviving in space in the long run, in a sustainable way, without depending on supplies coming from Earth all the time, is to harness the resources that are in the regolith. And that's what the SwampWorks does. It builds robots to excavate, to do space mining, to process the regolith, extract oxygen, and even things as exotic as helium-3. So that's what we do, what I do in my day job. But then I was a volunteer for the Institute of Electrical and Electronics Engineers, and they have a new initiative called the Telepresence Initiative. And they had the first annual conference for the Telepresence Initiative at Caltech University in Pasadena, California, last year. That's right next to the Jet Propulsion Lab, very famous university. And they approached me and said, we'd like to have a tele-robotics competition in an analog space environment. And just up the road from Pasadena, California, which is near Los Angeles, there's a desert, a Mojave Desert site, which is very space-like. There's no plants, it's arid, and it's very dry, very extreme environment. So we said, well, wouldn't that be great if we could have a telerobotics competition actually in the Mojave Desert? And we did that. And it's interesting because a team from Western Australia won the competition. And so that created a lot of interest in Western Australia. And they have a new test site, a new analog proving ground there, the AARP, AARP. And so one thing led to another, and we said, well, let's take it to Australia this year. And the idea is to always go somewhere that has interest in robotics, talent, and some kind of a good proving ground environment.
Well, you mentioned the AARP there. That's the Australian Automation and Robotics Precinct. And this also follows on our last year's Indo-Pacific Space and Earth Conference. We had a number of NASA people there as well, and we had a technical tour out to the AARP. So I think that was kind of the link there as well. We'll give Michelle Keegan a plug here as sort of bringing this together. But it's great to be welcoming this kind of sort of a competition, but also I was going to say a celebration of robotics, but it's not about it. It's a serious sort of research and trialing sort of aspect, but there's also a STEM aspect to this and bringing students in and future workforce development, right?
Yeah, let me explain this. When we started the telerobotics competition, I was asked to make it exciting and turn it into an event where the public would show up and enjoy it, be inspired, especially the next generation. We want high schools, middle schools, elementary schools, university students touring through. The problem was that when you have a robot driving around in a field and there's nobody there because the drivers are in Peru or Germany or Western Australia, it's not very exciting. And so very quickly I realized this was going to be a disaster. And I said, well, we can't really just have a robot driving around with nobody there. It just is not compelling. And so we started adding components to it. And we also want to make it exciting. We do want to make it fun. And especially for the youth, they need to be inspired by the robots, but also they need to see that this is a great environment to work in. And so we want to encourage a collaboration between space mining, and terrestrial mining, and automation and autonomy in general. And so I have another competition that I run called the Lunar competition, which is a NASA competition where we excavate the regolith with autonomous robots. And so it's amazing the quality of work that's happening in the universities. And we also have a partnership with the Australian Rover Challenge, and there's some amazing work going on in the Australian universities too. So when you take all this talent and you put it together and you have a competition, and then we're going to have a 3D printed robot for students that they can 3D print and build themselves. We'll have a pitch battle for startup companies, and we'll also have lectures. And then just to create this buzz, this excitement in the air, we'll have really good rock bands and food trucks, because everybody needs to be fed and happy. So if you add all that together, it's an event that you would like to attend. But here's really what's going on is we're promoting networking among various communities, technical communities. And then these companies that are coming in to demonstrate their robots, not only do they network with each other, but they can actually find talent. One of the biggest problems in the robotics industry today is finding talent. If you can find these students and young people and even other older professionals that are very experienced, if you can grab that talent, that's well worth it for the companies to attend. And there's a lot of components, a lot of moving parts here, but really what's going on is there's a lot of networking, and the talent gets to know each other, which creates a more vibrant robotics industry.
Well, I think that's the segue into IPRAAC, and I think that's 2 days of high-level conference where we can have those panelists and sort of really deep dive into some of the outcomes from ROBOPALOOZA, but also that additional networking and, again, from an Indo-Pacific and international aspect, bringing those people together and giving them a good purpose to come to Western Australia. Also, as a lead-up, an official adjacent event, I beg your pardon, to the IAC. So there will obviously be a strong space contingent in Australia in Sydney, and we want them to get them over to Western Australia as well. There's a few other things here. You mentioned the STEM tours, build your own robot. There's a tech startup companies for the pitch battle, as well as some lectures and the like. We have covered this before, but I thought I might get your insights into the challenges within sort of moon rovers and robotics in space. Obviously, communications and power and the like. What is different about regolith that might be different to what we see in terrestrial environments? What is that challenge of the material itself?
Yeah, that's a great question, because when we have the university competition, the university teams show up and they're all scratching their heads saying, what's going on? This isn't behaving the way that the sand on our volleyball court behaved. And they take it to the beach or volleyball court or some other quarry and they test it in sand. But when we have the competition, we actually use a regolith simulant, and it turns out it's very different than sand. And the main thing is the particles are much, much smaller. So think of it like crushed glass, very sharp particles, but it's the consistency of talcum powder. So it's a very fine abrasive dust, and it gets everywhere. In fact, you shouldn't breathe it. If it gets into your lungs, it could cause problems later on inside your lungs. So we encourage everybody, we make everybody wear respirators so that these particles can never get into your lungs. So it is a very dusty material. They call it moon dust for a reason. It's sharp, small, tiny little particles. Some are submicron, It's between, most of the particles are between 20 and 100 microns. 80% is about 20 to 100 microns. So just a really fine powder. And think of putting that into a gear train. It gets past seals and it just grinds up the gears. It's also magnetic in some cases, and it can be attracted to motors and stick to them, or it can get into your cooling systems and jam them up, or it can get into your electronics and short things out. So there are just a lot of things that can go wrong with the regolith. And but the whole point is to test and test some more. And we have come up with solutions, special seals, special coatings for surfaces. We have something called the electrodynamic dust shield, which is actually a magnetic electromagnetic field that creates a pulse, and the pulse pushes the dust off. So there's a lot of research and innovation happening to tackle this moon dust problem.
Well, the other one, I was at Kennedy Space Center in February, interviewing NASA, and that was just prior to the IM2 mission to the moon with the Trident drill. So it's not just robotics, but there's also other mechanics going on, and drilling and digging and sort of on ground experimentation. Does ROBOPALOOZA sort of go outside that, or is it just about sort of the rover aspect, or are you looking for other sort of solutions outside of just things that can move around, but that can actually be operational?
Yeah, absolutely. It's about mining in space, and that's why Perth is such a perfect location for this. The mining industry in Perth is so strong, and they have embraced autonomy and advanced sensing. So yes, the mobility is important, but the payloads are just as important, and the sensors are very important. And how do you operate, for example, in a dusty environment if the sensors are blinded? Or if they're destroyed somehow by the rocket plume exhaust. So there are a lot of things to think about, and it's not just the mobile robot. It's the payloads, the drills, the prospecting, the mining, and then extracting the resources from the ore. And of course, Western Australia knows how to do this very well. So we'd like to bring the terrestrial miners together with space miners, and then do a little bit of tech transfer. And so we'll bring all the technologies we have. For example, we have a LIB system, laser-induced breakdown spectroscopy with downhole sensing. I don't think the mining industry is using that yet, but we certainly have technologies that we've used on Mars and other places that we could share with industry. And then in return, we'd like industry to share their operational experiences with us, because operating in the outback is no joke.
Absolutely.
And so we'd like to learn from the industry, and in exchange, we'd like to give them our advanced technologies.
Well, I suppose one final thing is the skill sets. We talked about the range of problems and the technical challenges here, and when we talk about STEM, is there any shortage of skill sets in particular, or really does anyone with a technical interest they can find a place here, right? There's no shortage of opportunity.
Yeah, so these are 21st century skills, and you have to know how to use a LiDAR to map your surroundings. Then you have to know how to take that file and turn it into a CAD model, and then extract the topography from it so that you can then find out what your terrain is like. And then you have to do that in real time on the fly, because you're changing the terrain by excavating it. So this is a whole order of magnitude more difficult than a self-driving car. The self-driving car has the road, has the stripes, has fiducials. It knows exactly the environment it's in. It's a very controlled environment. But now if you take a self-driving car and turn it into a self-driving truck or a self-driving front-end loader, you're in a very different environment. It's a environment that's constantly changing. And so the difficulty of self-driving equipment and autonomous equipment in general is much, much harder. And then you put that into the space environment, which is a vacuum, extreme temperatures, and just this dust everywhere. And there's even moonquakes and micrometeorites coming in.
The
There's a lot to think
radiation.
about. And then the lunar day lasts 14 Earth days, so you might lose sunlight for 14 days. Now you're operating in the dark. You have to have power to operate the 14 days before the sun comes back up. And there's even craters, permanently shadowed craters at the South Pole and North Pole that are 40 Kelvin in temperature. That's 40 degrees above absolute zero. It's one of the coldest places in our solar system.
What's your vision, Rob, just with that environment as you've explained it? Do you anticipate Moon and Mars colonies? We will solve these problems?
Yes, but at first it will be robots. It's too hazardous for humans. It's not responsible to send humans into a hazardous environment without some kind of infrastructure, some kind of preparation. And that's what the robots will do. And that's why we're doing this telerobotics competition, because these 21st century skills, they're all about driving a robot on another planetary surface. We need people who are trained to do that, who understand that. And so we'll have people working on Earth. They'll check in the morning and they'll go to work on the moon. And then in the evening, they'll check out and they'll go home for dinner. So this is quite an amazing opportunity we have. And so that's the vision we're promoting, is that people will be working on the moon and Mars and asteroids with telerobotics. And they will be mining resources and building structures out of resources so that we can protect the humans when they arrive. And then the humans can go and they can live, work, and play there. But the real benefit of going into space is the amount of resources we have in space. There are billions and billions of times the resources that we have on Earth just in our solar system. And I'm not talking about anything beyond our solar system, because that's not probably attainable in our lifetime. But in our lifetime, we can go to the moon, we can go to Mars, we can go to the asteroid belt, and we can mine the resources and create a solar system economy that will bring fabulous wealth to the human race. It will create abundance for everybody. But first, we have to learn how to do it. And that's where the robots come in. And humans
Well,
will not
and
go into space until the robots have built something for them to use.
Well, I think that's the key part here, is that the journey has started. It's been going for many decades, obviously, but it's definitely starting to get serious. We're landing on asteroids. As I mentioned, the Trident drill didn't quite work. Well, it worked, but didn't quite achieve its full mission. But we're actually doing it, and I think ROBOPALOOZA is another step forward in that regards. So that's going to be at in Western Australia, in Perth, October 5 to the 6th, at the Australian Automation and Robotics Precinct. And then following that, immediately the 7th and the 8th, is the Indo-Pacific Robotics, Autonomy and AI Conference and Exhibition. Rob, we'll welcome you there as a speaker naturally also. And the websites and the like will be available on the show notes. But Rob Mueller, there in Florida, near or at the Kennedy Space Center, second annual ROBOPALOOZA.space Robotics Festival founder. Looking forward to welcoming you in Perth, Australia later in the year. And thank you very much for joining us on Australia in Space TV.
Thank you. I'm looking forward to visiting Perth, and I think it will be very interesting and a lot of fun.